Bismillahirrahmanirrahim. How are you, students? Today we will start a new chapter, unit number 5, lecture number 21, subject physics. Name of chapter is rotational and circular motion. Rotational and circular motion. Chapter number 5, rotational and circular motion. Now, before going into detail of angular motion, first I will explain rotational motion and circular motion. So, rotational motion, rotational motion. Rotational motion around fx axis. Motion around a line. Circular motion is around a point. So, if a body is moving in circular path, and it is, for example, the motion of electron around the nucleus is circular motion. Rotational motion, the spinning motion of Earth around its axis is rotational motion. So we should differentiate between rotational motion and circular motion. So today is chapter number 5, rotational and circular motion. We will first start angular motion. Until now, we studied in the previous classes linear motion. So we use most of the representation for velocity, speed of linear quantities. So now we will do for angular quantities. The simplest angular motion is one in which the body moves along a curved path. If a body is moving in a curved path at a constant angular velocity, the motion is supposed to be angular motion, as when a runner travels along a circular path or an automobile rounds a curve. The car begins to skid on the curve when the centrifugal force is greater than the frictional force. So, the motion of a body in a curved path, if body is moving in this curved path, it is called angular motion. Angular motion. The motion of a stone, a car moving around a corner, a satellite orbiting around the earth, the motion of fans, wheels motion of moon, wheels motion, the motion of wheels, motion of moon around the earth, all are the example of angular motion. Now, next is angular displacement. So, angular displacement is the angle. Angular motion, this is still angular motion, but we should explain angular displacement. Angular displacement. Here, angular motion involves rotation, circular motion. Some elements of circular motion have already been discussed and will be reviewed them here. Circular motion. This is for you, can be measured using linear units or angular units. Angular units refers to revolution, degree, and radian. These are angular units. The properties of a circular motion include displacement, velocity, acceleration. When applied to rotation, the values become angular displacement, angular velocity, angular acceleration. Additionally, angular motion can be measured using frequencies and time period. Okay. The Greek letter theta, omega, and alpha are used to represent angular displacement, angular velocity, and angular acceleration. For acceleration, alpha, theta, and for velocity, omega. Angular displacement. So for angular displacement, we will use theta. Describes the angle or degrees of an object may be rotated about some fixed axis. This is comparable to displacement in linear motion. For example, you have circular motion. This is the center. The body is here. Body is displaced from this position to this position, from A position to B position. So theta is 90 degree. So angular displacement is 90 degree. Angular displacement is 90 degree. So the angle which specifies the location between 2 points in a circular path. If a body is rotating in circular path and you use the angle to specify the position, then that angle is called angular displacement. Angular velocity omega, symbolically measured by omega, measures in revolution per second, vibration per second, radian per second, rotation per second. In linear of straight line motion, we had the velocity. Remember that velocity, how fast an object goes in a particular direction. Now we are concerned about how fast an object rotates or spins. This direction of spins will be clockwise or counterclockwise. Angular acceleration, alpha, is the rate of change of angular velocity. It is measured in revolution per second square, revolution, vibration per second, rotation per second, radian per second, these. Now, this is the unit and explanation of unit, but now we will go into detail of radian. So, I will explain some things beyond this. Now, by definition, that we already done, that radian is the unit of displacement. Radian is the unit of displacement. And 1 radian will be equal to this is a circle. This is the radius. This is B point, this is A point. If the length of this arc length is equal to the radius of the circle, then this angle is supposed to be 1 radian. 1 radian. Now, in complete rotation, one complete rotation have 2 pi radian. And one complete rotation have 360 degree. 360 degree. So 2 pi radian have is equal to 360 degree, because 360 degree a body covers 360 degree in one rotation and 2 pi radian in one rotation. So 1 radian is equal to 360 divided by 2 pi, which is equal to 57.13 degree. 57.3 degree. So 1 radian is equal to 57.3 degree. We will do it later again. Now, angular motion and definitions. We can find the direction of angular displacement, angular velocity by using different rules. For angular displacement, we use an angular velocity, we use right-hand rule. Angular velocity is a vector quantity. The direction of angular velocity can be find out by using right-hand rule. Now, this is the diagram. This is also, we will explain in this diagram. The body is rotating in anti-clockwise direction. So curves the finger of right hand in the in the direction of motion. The thumb will give you the direction of angular velocity. The rotation is reverse. So the direction of angular velocity also reverses. Now, S is the arc of the arc length between A point and B point. Arc length is S, and this is since for a full circle, circumference will be equal to 2 pi r. Circumference will be equal to 2 pi r. Then 2 pi radian is equal to 360 degree, and 1 radian is equal to, this is the derivation. Theta is the angular displacement, which is equal to linear displacement divided by radius of circle. So if a body covers from A point, the body covers this distance. distances, and this is the radius. So dividing radius by dividing the length of arc by the radius, you will get angular displacement. So if the body covers one complete rotation, which is equal to 2 pi r, covers a linear distance equal to the circumference. Circumference 2 pi r covers a distance equal to the circumference, then angular displacement will be 2 pi radian. 2 pi radian. Now, again the explanation, angular velocity and acceleration. Angular displacement is equal to this, theta is equal to s divided by r. Theta in 1 radian is equal to 360 divided by 2 phi is equal to 57 point this. Now, here average angular velocity is equal to this. Del theta is the angular displacement. Omega is the rotation, is the angular velocity. This is angular velocity. This is the relation between linear distance. This is equal to r theta. Theta is the angular displacement, r is the radius, this is the linear displacement. V is equal to r omega. V is the linear and omega is the angular velocity. So this is the relation between these two quantities, and we will derive it right now. Now, I will explain angular displacement, velocity, and this one. Angular displacement represented by theta, time, radius. Now, in this case, angular displacement, this is the change in angular displacement, initial angle and final angle. This is with respect to time, and this is the angular velocity. Angular velocity is the change in displacement divided by time. Angular acceleration is the change in angular velocity with respect to time. Now, the explanation of angular velocity. To describe angular motion, we need to introduce the idea of angular velocity. Average angular velocity, angular displacement divided by time, and do this. Omega is equal to change in angular velocity and now angular velocity is equal to del theta divided by del t. So SI unit of angular velocity is radian per second. Revolution per minute is also the unit. Now here linear quantities are written, and there is symbolic representation in rotational rotational quantities is also written. For example, position is represented by x, and it is in angular analogy, it is theta, angular position. Angular velocity, linear velocity is represented by v, and angular velocity is represented by omega. Angular acceleration is represented by a, and angular acceleration by alpha. This is the linear equation, which is s is equal to vt is equal to x is equal to vt when x is represented by x. This is this equation. It is written theta is equal to omega t. First equation of motion, omega is equal to omega I plus alpha t. You can write it like this. Final velocity is equal to omega I plus alpha t. This is v is equal to vi plus at. Linear quantities by angular quantities. Now, second equation of motion, third equation of motion, mass is represented by inertia, replaced by linear inertia, angular inertia, moment of inertia. F is equal to ma is replaced by torque, analogy, momentum by angular momentum, work done by this one, angular work, kinetic energy, power. Angular velocity. The angular velocity is defined as the rate of change of angular displacement n is vector quantity which specify angular speed of an object, and the axis about which the object is rotating. Angular velocity can be expressed as theta omega is equal to theta divided by t. Angular velocity, right? Angular velocity t is equal to angular displacement per unit time. So omega is equal to theta divided by t. Now you can find the direction of angular velocity by using right hand rule. This is the rotation. Keep the fingers, curves the finger in the direction of rotation, the thumb will give you the direction of angular velocity. Now I will write some quantities which relate linear quantities and angular quantities. As we know that S is equal to R theta. The S is the linear displacement, and theta is the angular displacement. So this equation relates linear displacement with angular displacement. So write S divided by T, dividing both sides by S divided by T. This will give you angular linear velocity, and this will give you angular velocity. So V is equal to R omega is an equation which relates linear velocity with the angular velocity. So write V is equal to R omega multiplied by del. We will write R del W means change in velocity. Radius of a circle cannot be changed, so del R cannot be. You cannot write del R because radius of a circle does not change. So if linear velocity changes, angular velocity will also change. So del V divided by del T is equal to R del W divided by del T, dividing both sides by del T. Here, linear acceleration is equal to R alpha, angular acceleration. This is angular acceleration, this is linear velocity. Now, remember this point. If you have a different circle having common center, this is different circle having common center, and you draw a line. This is A prime, this is a double prime. And you take this is B, this is B prime, this is B double prime. Here linear velocity is V. Here linear velocity is V prime, and here linear velocity is V double prime. Here linear displacement is S prime, S double prime. Here linear displacement is more. Here linear displacement is less. Here is more less. So S is less than S prime is less than S double prime. So on same line, different points. On same line, different points on different circle, and on the other line, different points on different circle will have different linear displacement. So this displacement, and this displacement will be different. But if you check, the angular displacement will be same. I will draw again. You have a circle, this one, this circle, and this circle. So this is a line. This is the other line. S prime, S double prime, S triple double prime. This is S prime, S double prime. Here is theta. So for this circle, angular displacement is same. Here the angular displacement is same. Here also the angular displacement is same. So different points on different circle on the same line. On the same line, different points and on different circle will have different angular displacement. Different angular displacement will be different, and linear displacement will be same. Different points on the same line in different circle will have same linear velocity, linear velocity, linear displacement, and linear acceleration. But angular displacement will be different, angular velocity will be different, and angular acceleration will be different. So different points on the same circle will have same linear quantities, but different angular quantities. Again, this is circle. This is also a circle. Here you draw. This is same line. Line is same. This is point A prime. This is different line. So distance between two same line. Distance between the two same line. The linear distance between different point. This is one point, this is S, and here is S prime. So this linear displacement will be more than this one. So linear displacement will be different on between same line on different circle. So linear displacement will be different on same line in different circle, and angular displacement will be same. Angular displacement will be same, because if theta is 90 degree for this point and this point 30 degree, for this it will be also same. So if you take a different point on different circle between same lines, linear distance, linear velocity, linear acceleration will remain same. Linear quantities will remain same, but angular quantities will be different. It will change. Between angular quantities will remain same. Angular quantities will remain same and linear quantities will be different. So if you take two same lines on different circle and you take measurement for linear displacement, linear velocity, and linear acceleration, it will remain, it will be different on different circles but on same lines. And angular quantities, angular displacement, angular velocity, and angular acceleration will be same on the same lines between different circles. Thank you, students. Next time we will study centripetal force. Wish you best of luck. Allah Hafiz, students.